don't know, I put together a guest lecture series to supplement my course that I teach on this year. It's History of Renaissance Mathematics. So I wanted some other speakers to talk about other aspects of it, and I always invite a math historian as well, so my students get to hear some other mathematical point of view. So I'd like to introduce our speaker, Professor Jeffrey Suzuki. He's going to speak on, as you can see, Albrecht Dürer and mathematics, art, geometry, and printing. He's an associate professor of mathematics at Brooklyn College. He earned his PhD in mathematics from Boston University in 1996. He's the author of 2 textbooks on history of mathematics. This one right here, this is, for those of you who haven't read a history of mathematics textbooks, this is a typical looking one. They have a certain amount of heft. It goes from 4,000 years ago, ancient Babylonia, to the 20th century. So that's a typical size and book. That was published in 2001. He also recently published Mathematics in Historical Context, put out by the MAA, Mathematical Association of America, in 2009, where Professor Suzuki talks about the historical setting of the big moments in mathematics, a little more of the contextual setting. It's actually a book I'd like to get in the near future and read it, because that's where my interests are as well. He specializes in history of mathematics between 1500 and 1800, so our Renaissance course is right at the beginning of your period of interest. On a personal note, I know Jeff from Arithmos. That's where we first met, and it's an informal gathering, about a dozen or so math historians. We meet about 3 or 4 times a year in Connecticut. And I've probably shared the story with a few people. I don't know, Jeff, if you've heard it. When I first went, I was trying to meet Professor Rickey. I had seen him speak, and I needed to talk to him. He told me about Arithmos, and I'm thinking, I have to put together a course on 4,000 years of math history. I can't just sit here and read one book, because that's what we do in Arithmos. We read an original source. We might spend 2 days just reading a work by Newton or a work by Bernoulli or one of them. And I said, I don't have time to sit and read one source. I need history of mathematics books. I need the survey. And I went to the first meeting and just got totally hooked. And I've seen Jeff at several meetings, and so we share that. I also had a chance to see Jeff speak about teaching a non-Western history of non-Western mathematics course at New Orleans at the last MAA conference. I got to see Jeff speak. So please welcome me in joining Professor Jeff Suzuki.
Okay, so I was suggested that we talk about Albrecht Dürer, and my interest in Dürer goes back a couple of years, and one of the reasons that I find Dürer particularly interesting is that he is an artist whose work has a lot of mathematical content in it. And I'll make another point of this a little bit later on towards the end of the presentation, but one of my other interests is mathematics education and where mathematics curriculum is going. And one of the things that I've always felt is an underutilized resource for bringing people to mathematics, for reinforcing mathematics, is what you might consider to be the constructive arts, painting, drawing, woodcraft, and that sort of thing. And Dürer has a number of things that he does that really bring together this idea that if you want to do good art, you are simultaneously, while you're doing good art, you are in some sense also doing good mathematics. And we're fortunate in that Dürer went a little bit further than that. He actually wrote a book, a quote from there, called The Painter's Manual in 1525, which not only talks about this connection between the mathematics you really need to understand to become a good artist, but a little bit of, but Dürer actually goes into some detail about how all of these things fit together. So let's talk a little bit about that. Let's see if we can get this right now. Let's try that again. Okay, so just a quick overview of the historical background. Dürer is a Renaissance artist, and this is a term that originates in the course of the 15th century. Probably most famously appears in a collection of biographies by Giorgio Vasari called Lives of the Artist. And Vasari talks a little bit about this rebirth of classical forms, and the idea that we have, the sense that you get is that Greek and Roman civilization reached this ideal state of art and literature and various other cultural artifacts, and there was a degeneration through the Middle Age, and now we're back, and now we're in the Renaissance, and we want to bring back these ideal forms. But then the question you have to ask is, well, what are these classical forms? What are we really looking at? And so, just as a couple of quick examples, architecture is probably the most obvious. Over on the left-hand side, you have this barbaric sort of thing that was, that's obviously crude and very, very unclassical. This is Notre Dame in Paris, and in fact, the term Gothic architecture emerges during the Renaissance as a way of saying, well, obviously, only those uncultured Goths who invaded the Roman Empire in the 5th and 6th century would build these horrible things. Actually, Notre Dame is about 200 years old at that point, so several centuries after the Goths. And in contrast, what we see is over on the right-hand side, you have the Pantheon in Rome, and this is a very classic Roman style of building. We have domes, we have columns, we have this very, again, from the Renaissance perspective, this is perfection, and that's barbaric. So this is what we're aiming for, and that's what we're trying to avoid. Also, another just quick example here. I'm not sure how well we can see that, but in the visual arts, over on the left-hand side, you have a medieval book of hours, and you might not be able to see it very well here from this distance, but if you look closely at the Book of Hours over on the left-hand side versus this painting from the Vasco Reale, which is currently down in the Metropolitan Museum of Art, what we see is a difference between what you might think about as this sort of unrealistic depiction of space. We can see that this is obviously somebody's drawing of space, whereas over on the right-hand side we have something that looks a little bit more, that looks like a real scene, that actually looks like it's looking out onto a garden with some stone benches and so on. So we see that again in the viewpoint from the viewpoint of the Renaissance, we have this very nice, very realistic depiction of space here versus this medieval sloppy construction of space. And now, to some extent, that's particularly an artistic decision, but I will say there is one point where this does make a little bit of sense. One of the big changes that we see is in how we write things. And over on the left-hand side, we have a sample of what's called Merovingian minuscule. This is a writing of a typography that becomes common during about the 5th, 6th, and 7th centuries. And we'll get a closer view of this later on, but even from a distance, you probably get the sense that reading something in Merovingian minuscule is going to be very, very challenging. Actually, one person describing this has actually described it as trying to read this as a form of torture because the letters are so very difficult to read. Versus over on the right-hand side, again, very classical Latin, Roman-style lettering, very easy to read, and so we have our Latin capitals. And so, again, we have this sense that there's a difference between how classical civilization handled the arts and how medieval civilization handled the arts. And so one of the things we see is this, what you can think about is a quest for lost arts. What were the Greeks and Romans doing that allowed them to produce a civilization like this? And the problem that you run into is that you have a lot of artifacts. You have the Pantheon in Rome, you have buildings, you have some paintings, you have some sculptures, you have all of these artifacts, but for the most part you have very few documents that relate to what's going on behind the art. You can see what was done, but you don't know how it was done. And so during the Renaissance, there is, to some degree, a large element of what we would nowadays call reverse engineering. We know what the final result was. Let's see how we would get there. Now, to properly do the reverse engineering, what you want to do is you want to put yourself into the mindset of somebody in Greek and Roman civilization. You want to have the mindset that somebody in the Greek and in the classical civilization has before they go and produce a work of art. And so, to that extent, well, let's consider what we...
I'm not sure if it would work better maybe pointing up there. I haven't figured it out.
There.
Does it work any better?
It does work. Okay. Okay. All right. So let's take a look at what the educational background of someone in classical civilization is going through. And so this is a quick overview of what we might see as a classical education. We have a distinction between what are usually referred to as libera, the freemen, versus manos, the people who work with their hands. And when Plato describes this educational system for freemen, for the movers and shakers in society, as it were, he identifies four things as being particularly important, and those are usually nowadays described as arithmetic, which is closer to what we would think about as number theory. This isn't the mechanical aspect of adding, subtracting, multiplying, and so on, but this is what sort of properties do numbers have, and how do these numbers relate to each other. Geometry, fairly self-explanatory. It means pretty much the same thing in Plato's time as it does many centuries later. We're primarily focusing here on what we would nowadays call Euclidean geometry. And then music and astronomy. Here are two things. Music in particular are very has a rather different definition. What Plato is talking about as music is this idea that musical harmony, to some extent, is applied arithmetic. A little bit of music theory. Most of you may have heard of this idea that musical harmony originates in certain ratios between, for example, string lengths. If I take one string of a particular length and I take another string that's half the length, then if I pluck both strings simultaneously, the longer string will produce a note that to the ear sounds like a lower version of the shorter string. And so we have this 2-to-1 ratio, which corresponds to what we would call an octave. And there's other important musical ratios. A ratio of a fifth corresponds to a 3-to-2 ratio. A ratio of a fourth corresponds to a 4-to-3, and so on. And so there's this idea that these properties of numbers that you study in arithmetic, they are applied when you talk about musical harmonies. And finally, the fourth of the classical studies is astronomy, and here we can view astronomy as being a sort of applied geometry. And one of the important things that's worth pointing out here is mathematics is not a liberal art. Mathematics is actually all of the liberal arts. There is nothing besides mathematics in the liberal arts curriculum. Well, again, what we have in classical civilization as an ideal, unfortunately we see a degeneration of the philosophical tradition to some extent beginning with the first century Roman Empire and then continuing. Probably the best evidence of this is around 420, Martianus Capella writes this. You could call it a handbook, a textbook on the liberal arts, and this is known as the Marriage of Philo and Mercury. And the quick summary of it is the background is this wedding between Philo and Mercury, and each of the liberal arts gives as their wedding gift a lecture on their particular topic. And geometry is probably the most notorious here in that all of Euclid's geometry is reduced to a couple of statements about how you find areas and lengths, and a fairly long discourse on geography. So we've gone from what we can think about as a study of mathematics to something that is peripherally mathematical, but deals with a lot of things that we would not consider to be not to be proper mathematics. And again, a little bit later, Boethius sort of formalizes this distinction, and in particular the four liberal arts of arithmetic, geometry, music, and astronomy. And this is what becomes known as the quadrivium. And this is to some extent the basis for medieval education. So